Dear students, today we will solve the fifth numerical from chapter number 4, which is named as the turning effect of force. The numerical states that a crowbar is used to lift a box as shown in the given figure. If the downward force of 250 Newton is applied at the end of the bar, how much weight does the other end bear? The crowbar itself has a negligible weight. Dear students, this is the figure in which a hand is applying a force in the downward direction, and the magnitude of this force is given as 250 Newton, and the distance of this force from the fulcrum or the pivot point is 30 centimeter, and on the other side of the fulcrum, at a distance of 5 centimeter, a load is being lifted up. We are asked how much load will be lifted by this force, which is 250 Newton and which is acting a distance of 30 centimeter from the pivot point or the fulcrum. First of all, we write the data here. The downward force acting by the hand is 250 Newton. We know that the force is represented by F, and the force F is equal to 250 Newton. And the distance, if I say this distance as d1, this is equal to 30 centimeter. This is the distance of 30 centimeter. And the second distance, if I represent it by d2, it is equal to 5 centimeter. And we will have to calculate the weight of the object being lifted, that we represent it by w, and it is to be calculated. We put the question mark here. To solve this numerical, we use the principle of levers, which states that effort into effort arm is equal to load into load arm, or the force into force arm is equal to load into load arm. I write the principle of levers here. Principle of levers. This principle states that effort, here E stands for effort, and multiply by effort arm is equal to load multiply by load arm. Here effort is the force which is acting downward, and it is 250 Newton. I write here 250 multiply by effort arm is 30 centimeter, which is equal to load. It is the weight which is being lifted by the crowbar multiplied by load arm, and this load arm is 5 centimeter. Since we have to calculate weight, 250 multiplied by 30, and we will divide by 5 on the other side. And by cancelling this, we will get 5 5s are 25, and 50 with 30, it will give us 1500 Newton load can be lifted with the help of 250 Newton force, which is acting in the downward direction, and its distance from this fulcrum is 30 centimeters. I repeat this question once again for the revision. Force which is acting downward is 250 Newton, and its distance from the fulcrum, if I represent it by d1, this is 30 centimeter, and the second distance from the fulcrum to the other side, which is load, this distance is 5 centimeter, and weight which can be lifted with the help of this load is to be calculated. Then we will use the principle of levers here, which states that effort multiplied by effort R is equal to load multiplied by load R. Effort is 250 and effort R is 30, and load is weight which we have to find multiplied by load arm is 5 centimeter. Dividing by 5 on the other side, and after simplification we will get that weight is equal to 1500 Newton. One point, dear students, you must remember that I have not converted this centimeter and this centimeter into meters because they are being cancelled with each other. So there is no need to convert it to SI units. If you want, you can also convert it, and by simplifying this will also give the same answer. Thank you very much for watching this video. See you in next lesson.